Alright, this is the last video for section 4.6, and in this one we're going to do a problem just like the one we did in class together on the whiteboard on Thursday. And if you remember, in that one we talked about the conjugate theorem, which told us that if a polynomial has a root in the form of a plus root b, then its conjugate also had to be a root, which is a minus root b. Okay, so that was our conjugate theorem that told us if a rational conjugate was one of the solutions, then its conjugate had to also be a solution. Well, we also have the imaginary conjugate theorem, which tells us if we have an imaginary solution, then its conjugate must also be a solution. So in this case, we want to write a polynomial function that has rational coefficients, a leading coefficient of 1, and zeros 2 and 3 plus I. Well, here we know that these aren't the only two zeros, because one of them, 3 plus I, is imaginary, so its conjugate, 3 minus I, must also be a solution. So that's the key to this problem right here, is when you see that you've got a polynomial that has an imaginary solution, its conjugate also has to be 1. So that's the first step here, is knowing that we don't have just two zeros, we have 3. So for this one, what we're going to do is the same thing that we did in class. We're going to write all of the factors. So since 2 is a solution, we know x minus 2. And then we're also going to do x minus 3 plus I and x minus 3 minus I. So I'm just going to write this out, and then x minus 3 minus I is going to be the last one. So to find our polynomial, all we have to do are multiply these three factors together. So let's go through the steps. Again, we did this in class on Thursday, but this is just a refresher. And the key here is not only do you have complex or conjugate rational theorem, you have a conjugate imaginary theorem as well. So let's go through. So since we know that these are our factors right here, we're going to have to multiply all three of these together. Now, remember, I showed you that shortcut on Thursday to multiply these two together, your x minus 3 plus I, x minus 3 minus I. You can use that same shortcut that I showed you in class as far as rewriting your parentheses to make it a difference of squared problem. So let's go through and do that. So what we're going to do is, first thing we're doing is regrouping our terms. So that's what I was just talking about. You take your parentheses and you go ahead and you put them around your first terms, your x minus 3. So now we've got x minus 3 minus I times x minus 3 plus I. Well, we can really look at that, and that's the same as a minus b, a plus b. And if you remember, when you have a minus b times a plus b, that's just our difference of squares, and that ends up being a squared minus b squared when you multiply those together. So a squared minus b squared. So here, our a term is x minus 3, so this is just going to be x minus 3 squared, and then minus b squared, which b is just I, so it's just going to be minus I squared. Okay, so that's what this is going through. The regrouping of terms makes it so that when you multiply these together, you get to use this difference of squares pattern. So let's go through, and now we've got that simplified. So now we can go ahead and multiply this out. Well, x minus 3 squared is just x squared minus 6x plus 9. And then remember, I squared is equal to negative 1. So we just have minus negative 1. So that's just going to be plus 1 for us. So when we simplify this, we get x squared minus 6x plus 10. So you can see how that using that difference of squares pattern really helps simplify this process. Instead of having to multiply, three or two three-term factors together, you just go ahead and expand it using your difference of squares. So now we just have to multiply x minus 2 times x squared minus 6x plus 10. You guys all know how to do this, so I'm not going to write out all of the steps to that. But when we multiply it out, we get, here are all our terms, and then we have to go ahead and group together our like terms. So minus 6x squared minus 2x squared plus 10x plus 12x. And when we get those all together, we get x cubed minus 8x squared plus 22x minus 20. Now, we can check this by, sorry about that, we can check this plugging in any of our zeros, and it should work out to be equal to 0. So that's how you go ahead and you can find a polynomial if you know the zeros. And remember, if any of those zeros are imaginary, then you can just also include the conjugate in there as well. So what I want you guys to do, I'm going to have a couple questions that pop up about these questions. Go ahead and answer those now.